let's just do a quick review of some of the stuff we talked about last time, and then we'll jump into the combining random variables examples. So we started with this community college example where we were given a random variable, which was number of credits taken at a community college and their respective probabilities. We calculated the mean and standard deviation, and then we began to transform that variable, right? So first thing we did was convert it to tuition, and that was by multiplying it by 50, and we computed the mean and standard deviation of tuition, and we found that a multiplier will impact both measures of center and measures of spread, and you would multiply the mean and the standard deviation by that factor to get the new mean and the new standard deviation. And then we did an addition. So we added the student fees, which was just an addition of $100 to every value of tuition. And we found that the mean and standard deviation were affected by addition or subtraction affects measures of center, but it does not change measures of spread. We just saw that in the warm-up as well. All right, and then here was kind of our summary of, we called that a linear transformation when there's a transformation that involves addition and or multiplication. All right, so what we ended with last time was talking about combining random variables, which is different than a transformation. So here we're taking two random variables and we're either adding or subtracting them. The way it works is that the mean, if you're adding two random variables, will just be the sum of the means of the original random variables. I discussed you have to know that they're independent to be able to combine them. And then this was the weird one, right? You cannot add standard deviations. Instead, what you have to do is add variance. And then if you want to find the new standard deviation, so if I want to find sigma t, I just take the square root of the sum of the original variance. I think that's as far as we got. And then we were about to start working on this example. So in earlier examples, we defined X as the number of units for a randomly selected full-time student at the main campus. And we're going to call Y the number of units for a randomly selected full-time student at the downtown campus. At the main campus, a full-time student pays $50 per unit. At the downtown, full-time students pay $55 per unit. So we're going to calculate the mean and standard deviation of the total amount of tuition for a randomly selected full-time student at the main campus and a randomly selected full-time student at the downtown campus together. So we're going to combine them. So if we selected one from each campus and we wanted to compute the total tuition for both. All right. Well, first, these are the summary statistics for the units. So the first thing we have to do is compute their tuitions, right? So it's $50 at Main and $55 at downtown. So the first thing I want to do is compute those. So I'll go mu of Tx, meaning the mean tuition for the main campus is, and we have a multiplier here, so that's just going to be 50 times the mean number of credits for the main campus, right? Which is 50 times 14.65. Okay. which is $732.50, right? All right, and then let's compute the standard deviation of tuition for the main campus. So sigma tx, and a multiplier also affects measures of spread in the same way. So we're just going to multiply 50 times the standard deviation of the number of credits for the main campus, which is 50 times 2.06. All right, which is $103. All right, so now let's compute the mean tuition for the downtown campus, so mu of ty. And that'll be 55 times the mean number of credits for the downtown campus, which is 55 times 15. All right, so the mean tuition for the downtown campus is $825. And then let's do the standard deviation for tuition in the downtown campus, which again is the same. It's a multiplier, so standard deviation is impacted in the same way. We're going to multiply 55 times the standard deviation in the number of credits. So 55 times sigma y, which is 55 times 2.3. All right, so we get a standard deviation of $126.50. Great. So now we have the mean and standard deviation for tuition for both campuses. And we can answer our question, which is calculate this mean and standard deviation of the total amount of tuition for a randomly selected full-time student at each campus. So basically what I want is mu of tx plus mu of ty, right? And that's just going to be my 732.50 plus 825. All right, so 1557.50. All right, and remembering that I cannot add standard deviations, what I would have to do to compute the new standard deviation, and actually let's name this. Let's say that this is the combined tuition. So I'll call that mu of TC, meaning the mean tuition combined. If I wanted to compute the standard deviation of the combined tuitions, I can't add standard deviations. What I would have to do is add the variances and then take the square root of those. All right, so I'll share my calculator just to kind of show you. You can do this all in one step in your calculator. Okay. So the standard deviations are 103 and 126.50 respectively. So I'm just going to do the square root of 103 squared plus 12650 squared. So that's all under the square root. All right, so I get 163.13 approximately. So I just want to show you that that is different. You can't just add standard deviations. If I added the standard deviations, I would have 103 plus 126.50. 229.50. That's a much larger number, right? All right. Real quick, I just wanted to point out, and I don't know how relevant this will be this year, because I suspect that you guys will be taking the AP exam at home. But these are not, my point is, these are not formulas that I need you to memorize. They're actually on the formula sheet that you're given, which I'll share with you real quick. And this is in our supplemental section of the Canvas page. And so here you have your formula for the mean and your formula for the standard deviation of a discrete random variable. Oh, you know what? They do not give you the formulas for combining. So you do need to remember that for combining the means, that's pretty intuitive, right? You just add the means. But for combining standard deviations, you need to remember that you have to add the variance and then take the square root. All right, let's see. I think there's another example, and if there's not, I actually have one that I want to look up to show you. All right, let's talk about when you're combining by subtraction. So if you're taking the difference of two random variables, x minus y, again, the mean is pretty intuitive. To find the expected difference, aka the mean difference, you just subtract the means. But to find the standard deviation, you still do the same thing as when you combined to find the standard deviation of a sum, which is you add the variance, and that'll give you the new variance. And to find the standard deviation, then you take the square root, okay? So even when you're subtracting, to find the new standard deviation, you add the variances and take the square root. All right, I should probably pause. All right, let's do it. All right, so now let's just say we want to find the difference in tuition charges from the two campuses. So now we're looking to combine, but through subtraction. So let's compute that, the mean and standard deviation of that. All right, and they've named the tuitions mu of t, mu of u. So let's go the mean, difference, and the order matters here. They've specified t minus u. So it's just going to be mu of t minus mu of u. So 732.50 minus 825 All right, so there's a difference of negative $92.50. So if we selected many students from each campus, there would be an average difference of $92.50 in tuition. And that's, I guess, Main minus downtown. Downtown. And I should say negative 92.50. Or you could say, I mean, you could word this in different ways, right? We could have said, on average, the main campus tuition would be $92.50 cheaper than the downtown campus. Either way works. All right. So now we want to find the standard deviation of the difference in tuitions. And again, you still add the variance and take the square root. So that's going to be root sigma t squared minus sigma u squared, or plus sigma u squared rather. So this is going to be no different than the standard deviation when we were adding them. So let me go back and figure out what that was. That's right here. That was 163.13. And again, interpretation would be if we selected many students from both campuses. Campi? But in this case, we'll say we would expect the difference in tuition to deviate from the mean for a typical student by about $163.13. Okay. So if a random variable is normally distributed, we can use its mean and standard deviation to compute probabilities. And note, any sum or difference of independent normal random variables is also normal. So if you're combining two random variables, x plus y, and you know that each one of them is normal, then the combination will also be normal. So you can basically compute a new mean, a new standard deviation, then you can use your calculator and normal CDF to compute probabilities for that new combined variable. So let's do an example Yo, I need to order. I was gonna order the new edition of our text for this year to get some new examples because our text is really good. It uses like all of the examples are real data. It comes from real life data. Um, but this one specifically starts to feel pretty dated because it's about speed dating, which was a thing that happened in like the early 2000s, I think. Oh, I guess I remember walking by when I lived in San Francisco, which was like 2009 to 2011. I walked by a bar on my way home, and there was like a speed dating event going on inside it when I looked in, and it was so bizarre. So this was a thing where they would do like, because I feel like now it's just gone to like whatever, Tinder, or like everybody's just, you can just have an app. You don't have to go to these weird social things. Um, anyway, you would like go to this thing and put on a name tag and by the way, I've never done this. I do not want you guys to think that I have. I uh, met my wife in a normal way, which was at a bar in college. Um, but you would go to you like go to a thing and put a name. All of my knowledge of this, by the way, is based off of movies from like the early 2000s. You go to a bar and like put on a name tag and sit in front of a person, and then they would like ding a bell. You would talk to them for like 10 minutes or whatever, and they would ding a bell, and then you would like shift positions in opposite directions. And then I don't know what would happen at the end of the night. You would like decide who you like best or write it down on a card, and if you matched with somebody, you would go on a date with them or something. Insane. But anyway, this was a real thing that happened.
I think most of us like basically know like what speed dating is because for all of like our activities in middle school, we would always do like speed dating, like kind of.
Oh, yeah. Is that
They would
true?
like
Bizarre.
they'd line us up in two rows and we'd like talk about whatever we researched or something like that for 30 seconds.
Oh,
But they said like, oh, speed dating,
they
blah blah
called it
blah.
that. That
Blah,
is
blah, blah.
so
Like
insane.
it's weird that it actually happens in real life. It was like fun with like sharing information, but like yeah, I know. It was yeah.
And then all the like 13 and 14-year-old boys in like 7th grade were like, ew, dating. And immature and fun.
That is insane. That sounds like such an ASA thing because that's like the way all of our like icebreakers before like faculty meetings are situated, and they're also extremely uncomfortable. Um, I can't believe that anybody would do this by choice, but yeah, that's like one of the main things I remember from my time in San Francisco. I have this like visceral memory of walking by this bar by my house and looking in, and that was happening, and I was like, whoa, these people are crazy. All right, so what we're going to look at is the height of M of male speed daters follows a normal distribution with a mean of 69.5 inches and a standard deviation of 4 inches. And the height F of female speed daters follows a normal distribution with a mean of 65 inches and a standard deviation of 3 inches. Okay, what is the probability that a randomly selected male speed dater is taller than a randomly selected female speed dater with whom he is paired? Okay. So this is a good example because it doesn't specifically say, hey, combine these distributions and then compute this probability. But it's implicit that we're going to have to combine these, and I'll show you why. So let's just use probability notation. What we're looking for is the probability that a male speed dater's height is taller than a female speed dater's height. So M is greater than F, right? And even there, we're not combining the distributions. But to answer this question, we are going to combine them. So what I'm going to do is subtract the female speed dater's height from both sides. So really what I'm looking for is the difference, m minus f, and I'm looking for the probability that that's greater than 0. And that's where you see the combination, right? All right. So to combine these, we're subtracting. So it's the difference. So the mean difference is just going to be the mean for males minus the mean for females, which is 69.5 minus 65. So the new mean is 4.5. And then we know to get a combination standard deviation, even if it's a difference, we have to add the variance. So I'm going to take the male variance, which is just the standard deviation squared. I'm going to add that to the female variance, and then I'm going to take the square root. So for that one, it's the square root of 4 squared plus 3 squared. Which, you know, that's a Pythagorean triple. Come on now. It's root 25, which is 5. All right. So here's the deal. We now have the combined, the difference. The mean difference is 4.5 inches, and the standard deviation for the difference is 5. And they told us that each one was normal. So the male height was normal and the female height was normal, meaning the difference in heights is also normal. So that's what I showed you on the last slide. So we know the difference follows a normal distribution with a mean of 4.5 and a standard deviation of 5. And we want the probability that that difference is greater than 0. So 0 is going to be somewhere over here, right? Not quite a full standard deviation to the left. So I probably put that kind of far left visually. So not a full standard deviation to the left. And we want to know the probability that it's greater than 5. So we want this area. All right, so that's going to be normal CDF and we'll go, the lower bound is 0, the upper bound is infinity, the mean is 4.5, and the standard deviation is 5. Right, then we'll pop that in our calculator. Oh, sorry, that's not the right place to go. Distribution, so second variables, normal CDF. Lower bound is 0, the upper is infinity, so I'll just leave a bunch of 9s there. Mean is 4.5, standard deviation is 5. And we get about 81.6% probability. So I'm going to just round it to 0.816. So with the statistics they gave us, there's about an 81.6% chance that the male speed dater is taller than the female speed dater. Don't know why that matters. If you're concerned with societal norms and the male has to be taller than the female, I don't know why you're doing an insane thing like speed dating in the first place, because that's not normal. Okay, so that's it.